Hi students, I want to help you with your class project, part 7 and part 8. I will show you in this video how to complete part 7 using a set of sample data. You can use the TI-84 or you can use StatCrunch, which is what I will show you in this video. And then another video separate from this I will post the link to that will help you with part 8, the chi-square test of independence. Both of these videos will be housed in YouTube, and I will post the link so you can access them. This project, assignment number 5, is due this Wednesday, June 3rd at 11:59 p.m. in Canvas. So what I'm going to do is type my information into a Word document, and I will make this Word document available to you as well. So project assignment 7, part 7 of the class project, is all about linear regression, least squares line. So I made some sample data, 20 sets of data, 20 interviews, if you call it that. I want to see if age is related to how much money is spent during the last trip taken to the grocery store. I entered my data into Excel using the file that you used for your spreadsheet, so it should look very similar. Please notice I have actually 4 sets of data here for 20 responses to 4 questions. The first one is, what is your age? The second one, what is your gender? The third question, how much did you spend the last time you visited the grocery store in dollars? And the fourth question, favorite kind of ice cream. For this part of the project assignment number 5, you will not be using question 2 or question 4. Those will be for part 8 of the project. So in my next video, I'll show you about how to use those. I've copied and pasted columns A and C into Word. Okay. And here they are. So again, I collected this data. What we're going to need to do with this data for chapter 10 is to, first of all, graph the data using an XY scatter plot, and also calculate some things. Calculate what's called the correlation coefficient, calculate the slope and the y-intercept of the regression line, and then we're going to do 2 things. One's called interpolation, and the next one's called extrapolation. And those are things we're going to get from StatCrunch. So let's go right here, and I'll show you how I got this graph from StatCrunch. So let me close out everything and start again so you can see how to do this. So if we were in our home of our Canvas course, here it is. Please click on My Lab and Mastering. And down here you see student links. That's all you'll see on this left side of this page. You won't see the instructor tools. But the My Lab and Mastering course home is where you will need to go. Click on that and let My Stat Lab open. And on the left side here you can see there's StatCrunch. I'm going to click on that. I'm going to visit the StatCrunch website. I'm going to click on the gold button here that says to open StatCrunch. So my data, oops, I'm sorry, I didn't mean to open my email. Let me cancel that. All right, there, Excel. My data is in Excel. I'm going to highlight these 4 columns of data, A through D. I'm going to do Control-C to copy them, and I'm going to minimize Excel, and then I'm just going to do Control-V, paste, and it will paste my 4 columns of data here into StatCrunch. So, stat, regression, simple linear. I need to tell StatCrunch where to find the data. I want my X value or variable to be the age, so I'm choosing var1 because this is what is your age. And then the Y variable will be variable 3. And notice those are the only choices you have for each of these pull-down menus because it needs numeric data. So to make a graph, an XY scatter plot, you need numbers. Can't use ice cream flavors or gender, doesn't work. So StatCrunch knows that. All I'm going to do now, I'm not going to worry about any of this, and I'm going to click on Compute. And notice that this window that pops up with the output has an arrow down here, has a left and a right arrow. The right arrow is active. I'm going to click on the right arrow, and there is my scatter plot. So use some tool that you have to take a picture of this. You can use a snipping tool that's in Windows, or if you have a Mac, you probably have a tool to take a picture of the screen, and that's what you will want to paste into your project. And see there, that's what I did. Don't forget to title this graph. I just put the title with age, variable 1, versus money spent during last grocery trip, variable 3. So I don't have to label the axes because I explained what they are in my title. All right. The next part is going back to StatCrunch. Remember this little arrow down here? Click on the left one, and here's the data that you'll need. So what did we need? We needed R, the correlation coefficient. There it is. It explains how correlated, or you can think of it as how close are the data points to the line. And R is between -1 and +1. The sign of R relates to the slope of the line. You can see this is a positive slope going upward. We would expect the slope to be positive number here, and therefore that's why R is also positive in this case. You could get a negative R, and that's fine. We also need here the intercept, the y-intercept right there, and the slope of the line right there. That's all, the only 3 things we'll need from this table. And notice that I just copied and pasted the table right into my project, and that's fine to do. So basically what we have is we have an equation of the line. Let me see if I can add this somewhere by making this a little bit smaller. There we go. So the equation of our line is going to be y equals, and it's a plus bx. So y equals a, which is our y-intercept. So 22.36, sorry, 236.135 plus the slope times x, plus b, which is the slope, 0.96161705 times x. All right, so that's our equation of our line. We need it because we're going to, for the next part, where we have to calculate the interpolation and the extrapolation, that's what we'll need. So let me page down here and show you that. So for the next part, interpolation, we're going to predict the money spent during the last trip to the grocery store for someone who is, and I chose 25 here. So please see the next note, that interpolation is choosing an x value, and it could be any x value you choose, that's within the range of the x values in the data. So for my project, if you look at my data, and I'm going back up here, if you see my data for age, the smallest or the youngest person was 17 who took my survey, and the oldest person was 62. So I want a number between 17 and 62. I could have chosen 50 or 60 or 20, and I just chose 25. So what am I doing? I'm taking this equation of my slope of my line, the equation of my line, and replacing x here with 25. And here it is right here. And you can see here's the answer that I got. And it's money, because remember, our Y is the money spent during the last trip to the grocery store. All right. So we're finding money. So it's dollars and cents. So that's why I did add the dollar sign and I rounded it to 2 decimal places. For extrapolation, you're doing the exact same thing, but the difference is that you're choosing a value, an X value, outside the range of the X values in the data. So for my project here, X will be smaller than 17, or it could be larger than 62. Let me go to the graph because I want to show you what this is really looking like. Interpolation, we chose 25, and we're going up to the line when we plug in X equals 25, and we're calculating what is Y. Okay, and it was $46 and change. Well, extrapolation, it's a little more risky because we really don't know what's happening to this line beyond X equals 62. We're predicting, we're guessing that this line would continue at the same slope that it had before age 62. And by age 70 then, which was the value I chose for my X when I'm extrapolating, again, it's like if we could draw this line and continue it out here, and I'm predicting what my Y, my money spent during the last grocery trip would be for someone who's 70. You can see this line has an upward slope. So we would expect, may not be true or not, but we would expect, and we see that we predict that someone who's 70 years old would spend about $89.55. According to my model here, my equation of my line is my model. So right here, what's highlighted, based on the data that I used to create my scatter plot. Bye.